Okay, so this is going to be lesson 2 on congruent segments and segment addition. All right, let's start with the warm-up. All right, you want to name each of the following in 2 different ways, right? So the first one is we have our line UEH. You can pick any 2 points and put them in any order you want, right? So I could say UH. That's one way to label this line. I could say HU. You could have also done UE and EU. You could have also done EH and HE. Pick any 2 of those 6. And you got the right answer. Okay, the next one is a line segment. So we want to make sure we have the whole entire line segment. So there's only 2 ways we can write this. You can do RK or KR. The last one we're going to be working on is a plane. So it is the plane that's cutting diagonally through my box right here. We just want to do, so we're going to say plane. Let's say JKH is one way. We're going to say plane IKJ, right? Just need three points to label a plane. Okay, and that is our warm-up. Okay, so today we're going to talk about congruent segments. Remember, congruent segments is just a segment where they have the same length. Okay, and typically, okay, so let's go ahead and label these links, right? We'll call this AB, we'll call this RS. If I want to say these 2 segments, if I want to say this segment is congruent or the same length as this segment, I would use a little symbol that looks something like this. Right? If we have multiple things that are congruent, I could also do 2 to distinguish between the different congruent markings. But I'm saying that AB is congruent to RS. And the way you would write this is we'd use this symbol here. It's kind of like an equal sign with a little squiggle above it. We would say AB is congruent to RS. Right? And that's how you would write that. Okay. A basic property in geometry is if we have a line segment, so we'll call this line segment AC, right? AC, and we're cutting that point by the point B. Essentially what this is saying is if I go AB plus BC equals the whole thing, right? That's what this is saying here. That's our segment addition postulate, okay? Those are going to be the 2 things we're going to be working on today. Okay, so let's go to the next page. We have example 1. We have 2 problems in example 1. Point I is on the line segment HJ. So it's going to draw that. We have a line segment HJ. We're told that a point I is somewhere along it, right? So I'm going to use a couple different colors to help me keep the numbers straight. So we have HI, this length right here is 3. We have IJ, which is going to be this length right here, is 5. And what we're looking for is the total, okay? If I want to do this mathematically, I'd set up the equation. I would say, hey, my line segment HJ equals HI plus IJ. I can substitute in, we get 3 plus 5. HJ equals 3 plus 5. Add those together and we get 8. Okay, that's letter A. And letter B, same idea. Go ahead and draw a line segment. I'd recommend drawing line segments anytime you have these types of problems, just to make your life a little easier. We have a point X on that line somewhere. We don't know where. So we know that the distance WX is 3. We know that XY is 11. And we're trying to find the total distance now. So I'm going to go and write an equation. We have WY equals WX plus XY. Substitute in, we get 3 plus 11 equals WY. Just bring that down. Well, 3 plus 11 is going to be 14. So our answer ends up being the total distance between W and Y is 14 units. And that's example 1. Example 2, same idea, but now we're going to do a little bit of algebra. Okay, so same stuff, just adding one more layer of complexity to it. So we have a segment CE. We have a point D on that line segment somewhere. Okay. All right, so we're told that DE is x plus 10. We know that CD is 6. And we now know that the total is 3x. So we're just going to use an equation to set this up, right? So we can do 3x equals 6 plus x plus 10, right? All I'm doing is I'm taking this from the equation that we built. We have 3x's right here. We have 6's right here. I'm just taking that length, this length right here, and I'm adding it to this length right here. Okay. Solve for x. And then once we have x, we're going to plug it into the part that we're looking for. In this equation, it's asking to determine the numerical length of DE. It's not asking for x. If you write x, you're going to get marked wrong. It's asking for the actual length of our segment here. So let's go first start by solving for x. We can combine like terms. We have 6 plus 10. I can combine these two numbers. So we get x plus 16 equals 3x. Bring that down. All right, so I have x on both sides of my equation, right? I want to move all my x's to one side. So we're going to start by subtracting both sides by x. So we get 0 over here. On the left-hand side, we have just 2x. So we're left with 2x equals 16. We want to get x by itself, so we have to divide. This is multiplication. The opposite of multiplication is division. So we get x equals 8, right? That is not my answer. We need DE, right? So DE, if we look back to what we were told, DE is right here. So we're going to do x plus 10 equals x plus 10. So I'm going to take this 8 and plug it in for x now. So we get 8 plus 10. DE is equal to 18. Okay, that's letter A. So letter B now, again, set it up. So we have a line segment, JL. We're told that a point K is somewhere on there, where JK is going to be 4x. We're told that JL, so that's going to be my total distance, is 2x plus 3. And that KL is just going to be x. Okay. Okay, so again, total length equals each segment added together. So we can write this as, we have 2x plus 3 equals 4x plus x. Again, all I'm doing is I'm taking the total length is right here is equal to this portion of my segment and this portion of my segment. Okay, so we have 4x plus x, that's going to be 5x. So now we have 2x plus 3 equals 5x. Again, we have 2 x's, we need to move one of the x's, so I'm going to subtract 2x from both sides. So we have 3 equals 3x. This is saying 3 times x, so to undo that, we're going to go ahead and divide by 3. So we get x equals 1. That is not my answer. See, even I made that mistake. I'm going a little too fast. Our final answer, what it's asking for, is the length of JL, so the whole entire line segment. So JL according to this right here is 2x plus 3. So we're going to do 2x plus 3. And we're going to go ahead and plug in 1. So we get 2 times 1 is 2. 2 plus 3 is 5. So my final answer ends up being 5. JL ends up being 5. Okay. All right. So that is lesson 2 for Math 1. If you have any questions, feel free to email me. I know Ms. Singh is going to be working with you guys in class, but again, if you have like the specific questions you need help with, please take a screenshot of it and email me and say, hey, Mr. Siegel, can you help me with this problem specifically? All right. Have a good day.